Hi everyone. It is Devi, Professor, Department of Electronics and Communication Engineering, Rohini College of Engineering and Technology. In this video lecture, we are going to learn about baseband pulse transmission, that is pulse shaping and correlative coding, and also with inter-symbol interference elimination techniques. So on completion of this module, the learners can able to understand pulse shaping and correlative coding for the elimination of inter-symbol interference ISI. So basically we have to know about pulse shaping. So we know that the binary data can be transmitted in baseband or passband. In passband transmission, the binary data modulates some carrier and modulated carrier is transmitted over a channel. But in baseband transmitted, there is no modulation of high frequency carrier. So where the pulse shaping is needed is one of the baseband system for transmission of digital data is discrete pulse amplitude system. So in this discrete pulse amplitude modulation, the amplitude of pulses varies in discrete manner according to the binary data. This PAM have only two amplitude levels, zeros and ones. So the successive binary bits can be combined into simples. So while transmitting, whenever noise affects this signal, the shape of this transmitted signal varies, so that the pulse shaping is important. It is the process of changing the waveform of the transmitted pulse, that is called as pulse shaping. So its purpose is to make the transmitted signal that is which is suitable for communication, that is it have the effective transmission, or it have error free transmission. By filtering the transmitted pulses in this way, the inter-symbol interference, that is ISI, can be under control. So we have to know the need of pulse shaping. So in radio frequency communication system, this shaping of pulses is essential. It is needed for making the signal that is fit in its frequency band, or else because of its shape, the pulse can be occupy the space of the adjacent pulses, so that it should be in the space which is fit for that particular pulse. Typically, this pulse shaping occurs after line coding of the modulation. So after modulation or line coding modulation, it is possible to do the pulse shaping. The transmitting signal at high modulation rate, that is shaped, and it is made to fit in the particular spectrum. So as this modulation rate increases, the signal's bandwidth increases. We know the relationship between the modulation and bandwidth. Both are having direct linear relationship. Whenever the signal's bandwidth becomes very larger, which is higher than the channel bandwidth, the channel starts to introduce the distortion, because whenever the always it is recommended to have the channel having the maximum bandwidth and signal which is lesser than the channel's bandwidth. Whenever the signal bandwidth is greater, it becomes to produce the distortion in the signal. So the distortion usually it is called as inter-symbol interference. So this signal spectrum, which is determined by the modulation scheme, so that the data rate which is used by the transmitter, that is which is modified to shape the pulse. So the pulse shaping can be possible, which is represented in the mathematical form as x of t. So x of t, which is given as x of t is equal to summation k equal to k to minus infinity to infinity. There is one relationship is there. So that relationship, that is ak into g of t minus ktb, that is simply g of t is the shaping of pulse. This is the relationship between this pulse shaping filter. So here the main important problem is, whenever optical fiber or twisted pair cable is used as communication channel, the shaping of pulse is little bit complex. The Fourier transform of sin x by x, that has a significant signal power at frequencies higher than the symbol rate. The signal x of t is simply the data transmission system, that is given by input transmitter and channel, finally receiver. So transmitter is having data encoding followed by transmitter filter and channel, and receiver having receiver filter followed by decision device. The RF systems can be there will be some base or bandwidth, and it is only the signals will fit in that spectrum, particular spectrum. If it exceeds that particular spectrum, the bandwidth will be based at it, so that the shaping of pulse is necessary. So always a typical non-return to zero coded signal is implicitly filtered with this sync filter. Sync is sin x by x. Always it is represented by like this. So here we are having on data 11011 0000100, which is represented like this, and for 0 it is off, and for 1 it is on, so that wherever 1 is there, it is represented as red line, which is in the positive half, and 0 is there, it is represented as off. So examples of pulse shaping filters are, commonly it is found in sync shaped filter, Rice quotient filter and Gaussian filter. These are the types of pulse shaped filter, and this is sync filter sin x by x for beta equal to 0, beta equal to 0.25 and 0.5 and finally 1. So here boxcar filter, it is a filter which is used for frequency domain equivalent filter, which is in rectangular shape. So theoretically non-Gaussian filter, which is relatively slowly decaying trace. Also the synchronization point is used to view the phase errors. So simply this pulse shaping is used for determining or identifying or reducing this intersymbol interference, the presence of output due to other bits. So the symbols which is interfere one to one, that is called as intersymbol interference. So the pulse shaping is for to avoid intersymbol interference. We have one quiz question based upon this. To reduce distortion, which one is used? Multiplexer, sampler, comparators and equalizers. We are using equalizers to reduce the distortion. So here in this module we learned about pulse shaping, which is to avoid intersymbol interference. Thank you.